Hi guys, welcome back to my channel and this is the day name of DSA bootcamp. I will be starting with problem of the day and lead code platform and the question number is 2096. The question name is step by step direction from the binary tree node to the another. You are given in a root of the binary tree. This is the root of the binary tree and n nodes and each node is a unique assigned a value from 1 to n and you are also given a start value representing the value of the start node and where we have to start and a different integer destination value representing the value of the destination node where we want to reach the stopping node and find the shortest path from the node as starting node and the ending node at the target node destination. Generate the step-by-step direction of such path as a string consisting of only uppercase letters, left, right directions, left, right, and U. Only three directions are I have to mention in the path, and each letter indicates the specific directions: left child, right child, parent, and you have to return the step-by-step direction to form a shortest path from the node starting node to the destination. That's the question. For example, here we have the binary tree given, and the starting node is 3 and destination node is 6, and we have to form here 3 goes to here up, and right and left. You can see up, right, and left. That is what the shortest path to reach from starting node 3 and destination 6. For the same here also the binary tree is given, starting node is 2 and destination value is 1. And as you can see, we are going from the starting left to right, starting node to destination as a left direction and the constraints are tree consists of n nodes and n will be ranges from 2 to 10 power 5 and node values will be ranges 1 to n only. Within this range only the node value will be there. All values in the trees are unique and one should be the starting nodes and the destination nodes are ranges from 1 to n and it should not be equal as at any point of time the test case are generated starting nodes are not equal to the ending node destination. Let's go to the notepad and this question was asked in many of the companies as you can see in last 6 months. Amazon twice and 6 to 10 1 year within that TikTok 3 times, Meta 2 times, and 1 to 2 years Google 13 times, and Microsoft and Databricks and 45. This is more important question, so please be careful and solving better. I'll be explaining two approaches. One will be the using LCS and DFS techniques, and also using backtracking approach and this comes under and the intuition is very simple. We have to find the lowest common ancestor from the starting node and the destination node. Whenever we form the lowest common ancestor, we have to form the path left starting node to the root and uh, route to right node and destination node. Those paths and we have to adjust accordingly. If you are going to the parent itself, you need to modify left to up so that we are moving parent and here the same will be same. So that is what the infusion and let's deep dive the algorithm how it works for this given question. As you can see, this is the 6 is the starting point, 4 is the ending point. As we can see, this is the 5 is the lowest common ancestor for both 6 and 4, and which having a common parent, having the common parent. That's called the LCA, least common ancestor. And with the help of least common ancestor, we can find the shortest path from the starting node and destination node, and we can adjust the form. And while going to the algorithm itself, let's try run few examples. Here we given LCA is 5 and destination value is 6. As you can see, first we have to go to the using DFS approach. We are going towards left first, and when we are going to the left direction, left subtree, we will be adding the path length also. The pointer move towards left direction, left subtree, and the path will be added, the direction will be added. And again, when we reach out to here, the path will consist of length, and then we have to backtrack because we can't find the node, the target node. So one L will be removed. The last direction will be removed. This is the direction, left direction has been removed with the help of backtracking. Using a DFS, we can add one line to use backtracking so that this will be helpful to many of the applications. And for similar for going for the right node, adding right and going for the left side as we are using DFS. First we are going for the left subtree and then right subtree to find the nodes itself. So R is added first and left R will be added. So we found the path from destination, route to destination, nothing but LCA to destination. So this path is considered into our answer. That's what we can return the path. When we found node is found, as you know, destination is found. This is one of the path. So we can return that path with the help of DFS and backtracking. We can solve it. Let's go to the code itself. This code is written in Java, and next time I will be on the next episode. I will be explaining in C++. Okay, I have to cover both the languages, and the given question gives the root nodes and starting value and destination value. First, as we discussed, we have to find the LCA. As you can see, we are finding LCA and left path and right path and combination. We are adjusting the building the result. So we will find the we are using the one black box here. The find the lowest common ancestor will be act as a black box function, which will find the lowest common ancestor with the help of starting node and destination node and the given group. It will find and it will return the root node tree node. And then we have to find the path from to the start, path to the start and path to the destination. With the help of DFS functions, the find path is a DFS function. With the help of LCA and starting value and the path, it is a string builder to store the path directions basically. And from LCA to the starting value, it will store this entire path, and this function will store the destination path to the destination from LCA to the destination. It will store the entire path. After that, the final result will be stored in this here direction. We have to update. As you can see, the given question states that we have three possible directions: left, right, and U. U indicates the parent. When we move up towards up, we have to use up, not left. Okay, but uh, mm, during backtracking only we can able to get the upper direction, so that we are adjusting all the path from LCA to the left child. We are adjusting to the upward direction, as you can see. So with the help of backtracking only, we can able to solve this with this approach. And directions we are appending U and repeat until the path length, path to the starting, which means that left subfill path we are adjusting all towards up as we are moving up, and then right towards right and left whatever the left right subfill. And after that we can simply add the right path to the append to the direction, and we can return the direction itself. And coming to the finding out the lowest common ancestor, this pretty basic question will be asked in one of the interviews. This has wider applications and wider problems on top of this. Given a node and values, two values, and left child value, right child value. These are the base conditions. If node is null, we can return null. If the node value is matching with any one of the child 1 and child 2, value 1 and value 2, we can return that node itself. The node will be act as an LCA, and we have to find the left side LCA and right side LCA by calling recursively to the node to the left, go to the left subtree, find the LCA of that, and same thing applicable for the right LCA. After finding sub, these are the main three conditions most commonly used in LCA. It's nothing but checking the LCA is null, which means we can't find the least common ancestor on the left subtree. So we can return the right LCA. We can consider right LCA, right subtree consists right LCA. And if the right LCA is null, then this is the case. Right subtree doesn't contain LCA, and we can return left LCA as an answer, consideration answer. If both are null, we can return the parent node itself, universal node itself, and LCA. So that is the edge cases by handling the LCA. And after that, the DFS function, the find path, basically it will find the path from the LCA to the starting node and the destination node by recursive calling. This is the path will be storing all the directions. So you can see the target value and the node. The target value can be in starting node or in destination node. So that's the reason we kept in target variable. And string builder will store the path from the LCA to the target node. And these are the base conditions. Node equal to null. If it is null, we can return false. And if we can able to solve the path, and node dot value is equal to target value, and we can stop the iteration. So that's return false. And we are going for the left subtree. As you can see, we are going left subtree by appending the value, by taking the consideration left and going for the left direction by recursively calling the find path and the target value and the path. Path is appended, right? So this will return from whenever we found that using the FS function recursively, we can return to, we can stop the iteration from there itself. And after that, we are removing the last character with the help of path dot set length. The path is a string builder dot set length, and we are removing the last one. Or we can use delete caret the particular index. This is the last index. We can return. Or we can set the length that will be trimmed off. So two tricks can be used for the removing the last character and going for the right words. It is a backtracking step for removing the character. This is backtracking, and this is also backtracking, remove the last character. While going for the right subtree, this similar mechanism will be applicable for the right subtree by adding the direction right and traversing recursively column to the right subtree. And if we found the path, we can return the true, find the variable, target variable. As you can see, we are finding the target variable and we are stopping there. There itself, we found the enough path, please return the path. So that's the reason we are returning and we are stopping at that when we found any particular target value. So we are appending right subtract, we are traversing right subtract, and we are reversing back. These two are backtracking steps, very very important. So as I mentioned, mm, we can optimize the above approach. By with this, we can solve this problem, and we can also optimize. And we have to give in the one more intuition, one more problem uh, to the interviewer. Like the interviewer also asked to optimize the solution. At the point of time, you can clearly observe that. For example, here this is the starting node, this is an ending node, destination node. As you can see, we are finding the least common ancestor here, and after that, we are this is the path will be this is the path will be taken into consideration for the left part starting node. Path to the starting path, we are storing this entire path instead of storing entire path and removing some part of it, by using DFS method. Why can't we avoid finding of least common ancestor, and why can't we find out the common path? Suppose here the root, instead of finding the least common ancestor, we are starting with the root node as usual, and we are finding the left path and we are finding the right path. After finding the left and right path, we can compare the which is the common path. As you can see here, here the common path will be the root to the least common ancestor, but we are not finding this because it will take another traversal technique to find out least common ancestor. Instead of that, we can avoid complete iteration, finding out least common factor. With the help of root only, we are finding the left path, starting path, and the ending path, destination. And we are using simple two-pointer approach to find the common portion. Here you can see this is the common portion for any of the given test cases. This will be find out with the help of least common ancestor node to the root. Root to the least common ancestor. This is the path is common for every path, every element. So we can avoid by using two pointer, and we can find that, and we can avoid least common ancestor finding out. It will reduce the, and it will use the shorter code also. That is what the intuition you can explain that. Finding it LCA and identifying the path from the LCA to both the nodes. This will take additional running time complexity, and it will again burden to maintain and to track everything. In order to avoid that, we can directly find the full path from the root node to the each node, and then we can trim their common path ourselves. This approach eliminates the explicitly finding on the LCM. Recursion calls will be reduced, and if the tree is more also, stack overflow doesn't occur. That is also very important. And significantly, the shorter code and simpler code. This helpful for the interview to code up easily within a short period of time, 5 minutes or 2 minutes, you can able to code it up. And given the question here, the question train over given starting value is the destination. I will be explaining C++ as I mentioned above. Java explained in C++ now. We will be taking two string starting node and destination, and this is the DFS call to find the root to path, find a path from the root to starting node and the destination node. This will store the start path will store the starting route to the starting node, and route to the destination node that will be stored with the help of DFS function. And after that, this is the direction will be a result storing the result, and common path using the two pointer technique. This is the common part, finding out the common path with the help of two pointers. You can see here the common path length, one of the thing, and with the help of checking here, start path length should not be exceeded, and also destination should not be exceeded, and we are mm, checking both the path string comparison if string starting path and destination path having the same occurrences. For example, we are doing left path, right and left we have, so that it will compare left and left, and if the left path and the right path consist of same attributes, then we can eliminate that. We can consider in the common path selection. We can add up, and after that, once we find out the common path, common portion, and then we can trim it out the common portion from the starting path. You can see that we are traversing from 0 to the path length, and we are trimming the common path length, and we are adding the directions to the upper, because even it doesn't matter left or right, whatever from the root to the left node, we have to add upper only, because we should move upwards. But while traversing the algorithms and DSA, ladder success will follow left and right, but we have to tilt the direction with the help of the resetting to you. After that, we have to we have to add the destination path to our answer. As you can see, this is the base conditions for finding DFS function and finding out the left direction. This is the backtracking step as I explained before. Same code for DFS, nothing doesn't change at all. And finding the common path, this is the portion comes into the play. And this is Java code, same, nothing else, same, everything is same. And time complexity linear and space complexity order of n. And yeah, that's all about. Thank you.